Day 101 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're at day 101. We've officially got over the 100-day hump. We're at day 101. Hope you guys are feeling good and feeling motivated because we're still going and we still have a lot to learn, y'all. But before we get started today, don't forget, bring a mouse right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash that like button for me. Then after you smash that like button, I'm calling all of my bankers to the comment section. I need you to drop 2 bank emojis in the comment section so we can run up this engagement and we can do our part in helping to build the Swift community as a whole, guys. We need to get more people interested in Swift so we could grow the Swift community and help it become one of the top programming languages out there. Now, with all that being said, y'all, I know why you're here. And today we have question number 1637, widest vertical area between 2 points containing no points. The difficulty level is easy, so you know we're going to keep the solution as simple and easy to understand as possible because there's no point in writing code that nobody understands. Right now, we're doing about a month of easy problems, easy array problems. Then we're going to do some easy strings, but we're really trying to get a grasp on on our fundamentals and build a foundation or start our foundation that we can build on as we continue on our LeetCode journey. So this question used to be a medium, now it's an easy. And so yeah, let's see what it says. It says, given endpoints on a 2D plane where points I equals xi and yi, return the widest vertical area between 2 points such that no points are inside the area. A vertical area is an area of fixed width extending infinitely along the y-axis, i.e. infinite height. The widest vertical area is the one with the maximum width. Note that points on the edge of a vertical area are not considered included in the area. So let's break that down. It seems like they make it seem a little confusing, but it's really not confusing. We just want to find the greatest area between 2 points, right? So we want to find the area, and we don't have to go diagonal. We're just going from here. So for these points, we're going from, we're only worried about the x-axis. We're not even worried about the y-axis because, like it said, the vertical area is an area fixed extending infinitely. So we don't even have to worry about the y-axis because that's the infinite height. We're looking at the x-axis and we're trying to find the widest vertical area between 2 points such that no points are inside of the area. So we want to measure the distance from this point to this point, but imagine that they're right next to each other. We don't have to go diagonal. We're just checking the x-axis. But we can't since this point is right here, we can't include this point to this point, right? So we can't go from 7 to 9 because there's a point right here, 8. And right here it says between 2 points that no points are inside of the area. So that means we can't go from here to here. That would go 7 to 9, that would be 2. Nah, we can't do it like that. But we can go from here to here. We could go from 7 to 8 because there's a point on 7 and there's a point on 8. So we could go from 7 to 8, boom, as far as the x-axis goes. So we could go from 7 to 8, that's 1. We could go from 8 to 9, that's 1. And if we did these points, it would just be 0. So we don't even have to include this, but we want the maximum. So in this case, the input points in the 2D array of integers. We have the 8, 7, that's a point, then 9, 9, then 7, 4, then 9, 7. The output is 1. It says the explanation says both the red and blue area are optimal. So the greatest point from here to here would be 1 because we're going from 7 to 8 on the x-axis. That's all we worried about is the x-axis. So that would be 1. Then from here to here, that would be 1 as well because we're going from 8 to 9 on the x-axis. These, we're going from 9 to 9, so this would be 0. But we want the greatest, right? So the greatest would be 1 because this is 1 and this is 1. So Now that we understand what the question is, we're really just measuring the distance between 2 points, and as long as there are no points inside of the area, you know what I'm saying? So that's why we can't go from here, from this point. That's why we can't measure the distance from this point to this point on 9, from 7 to 9, because there's a point on 8, and that would break this rule where it's a point inside the area. So there can't be any points inside the area, so we would have to go from 7 to 8, and here we'd have to go from 8 to 9. This would be 9 to 9, so this would be 0. So that's why we can't go from 7 to 9. But now that we understand what the question is asking, let's get into the code. The code is not that difficult at all, y'all. So let's go into it and break it down and see what we come up with. The first thing we are going to do is we are going to declare a constant called n. We're going to set that equal to points.count. So that's going to just count the number of points we have. Then we're going to say guard n is greater than 1, else we are going to return 0. So if there's no points, then we're just going to automatically return 0, and we're just going to stop that and nip that in the bud right there. Then we're going to come down here, we're going to sort the points. So we're going to say let sorted points equal points dot map. Then we're going to open up the brackets. We're going to bring $0. We're going to say open up the array brackets and put a 0. Then we're going to come outside and we are going to say sorted, open up the parentheses by, then we're going to put the colon, then we're going to put this, that is the less than greater than sign. So we're going to sort them and from smallest to largest. And what this is going to do, what this represents right here, this is going to represent each point that we're working with in our array, guys. So that's what that $0 is. It represents each element in the array. In this case, it represents each point in the array. So then we're going to come down here. We're going to declare another variable called res. We're going to set that equal to 0. We're going to come underneath that and we're going to start our for loop, and we're going to say for I n 1 up to n.count. Then we are going to open up the brackets and we are going to say res equals max, open up the parentheses, max, and this is going to get us, we're going to put res right here, and this is going to give us the max of either the result or the sorted. We're going to say sorted points, sorted points, open up the array brackets and put an I. Then we're going to say minus sorted points, open up the array brackets, say I minus 1. That's going to give us the maximum value between those two, whatever the result is, or whatever the product or sum, or whatever the difference is between sorted points I and sorted points I minus 1. Whichever one is greatest, that's the one that we're going to return. Then we're going to come down here and we're going to just say return res, y'all. And that's all she wrote. Not too much code, at all. Let's run it and see how it runs. Hopefully it runs well. Let's see. Okay, so we have a typo, and the typo says, guys, we could remove the count. We could just say n, because up here we already set n's as points.count, so we don't have to put a .count here. So let's run it again and see what we get. Ooh, okay, cannot find sorted point in scope. So that means there's a typo. So let's see. It should be sorted points, not S. With the S, coming from right here. So it should be sorted points, not sorted points. Guys. So let's run it again, see what happens, and it's accepted, y'all. So let's submit it and see if it stays accepted. Hopefully it does. It should. I don't know why it wouldn't, but you never know. And there it is, guys. 646 milliseconds beats 77.27% of users with Swift. That's what I like to see, y'all. That's what I like to see. So get one more look at the code. Y'all. one more look, get one more look. And I hope to see y'all tomorrow for another day, another LeetCode problem. See you then.